Okay, I want to give you a quick refresher reminder about the rules of factoring, and then we'll go quickly through some perfect square trinomials and difference of two squares, which is the next assignment after the factoring thing. I'm trying to make this fast. I'm going to go through it kind of quick, but you should be able to pause and go back and relook at some stuff so that you can see what I did and how I did it, so that you can get your homework right, hopefully, the first time. So, remember the rules of factoring. If it says ax squared plus bx plus c, your signs in the middle are going to be plus and plus because this is positive and so is this. If it says ax squared minus bx plus c, these are both going to be minus because they have to multiply to a positive and add to a negative. If it says ax squared plus bx minus c, or ax squared minus bx minus c, they're going to be plus minus or minus plus. Because in this case, they have to multiply to a negative, so one's got to be positive, one's got to be negative, and then they've either got to add or subtract to get the middle one. Okay? So those are your four basic types of those that you have to be able to understand in order to factor properly. Look at what the signs are in it. That tells you what signs go in parentheses. Then it's factors of the last term, factors of the first term, and so on. I think that part you understood, but the other part was a little trickier. So then I want to talk about perfect square trinomials and the difference of two squares. Okay? So a perfect square trinomial only works if you look at your PowerPoint slides. It talks about a trinomial is a perfect square if the first and the last term are both perfect square numbers. So if the first term is an x squared term, like 4x squared, 4 is a perfect square number, x squared is a perfect square, so you can do that. X to the third power is not a perfect square. X to the fourth power is a perfect square because that is x squared and x squared when you break it apart. So you've got to keep all those things in mind. Same thing works for the back one. Is there one number that multiplies it by itself to get to that number? So 64 is 8 times 8 type of thing. Okay, so that's the first part of that. Then you have to be able to put it together to get that middle term. So let's do an example. If I said that x squared plus 6x plus 9. We just got done saying that x squared is a perfect square, so we know that's a perfect square. Check, that's a square. 9. It's 3 times 3. It's a perfect square. Check. So now we know that it could just be whatever they are, x plus 3 plus plus, so we know that it's plus plus, x plus 3, 3x, 3x, 6x, I've got it, x plus 3 squared. Not hard, but you've got to be able to recognize it. Okay, it works the same way if we did a minus. How about we do x squared minus 2x minus, well, plus 1. Now we see it's minus plus, so what's that tell us from over here on that other thing? Minus plus means that it's going to be one of them's, they've both got to be either positive or negative. Since this is negative, they're both negative. So we know it's minus minus. X squared is a perfect square number. Is 1 a perfect square number? Yes, it is, because it's 1 and 1. So x minus 1 times x minus 1 is equal to x minus 1 squared. So those are the way you should write those two answers. Okay? The last one I want to go through is the difference of two squares. And this one is pretty noticeable when you do it right away because there's only two terms with it. Because the middle terms disappeared. So there is no x term. There's an x squared term and there's a constant. But we have to be able to do it the other way. So how we're going to approach that one is we're going to take something like x squared minus 9. There's no x term here, so how could I have gotten to this? If this is a perfect square number, it's x. Because there's a minus here, we automatically know that this is a plus and a minus. So this is another rule of factoring. Since it's minus, minus. The difference of two squares will always look like a minus sign in the middle. If there's a plus sign in the middle, it's not going to work. Okay? So, square this. 3x3. So x plus 3, x minus 3. How do we know that works? If I FOIL it back together. X squared minus 3x plus 3x minus 9. Those two terms cancel. I'm left with x squared minus 9. Okay, let's try one with some variables. Let's do the one from your PowerPoint. If you're looking at your PowerPoints, you should be able to figure some of these out. 3p to the 4th, 3p squared minus 9q to the 4th. Well, is 3 a perfect square number? No. 9 is. So we got a little problem here right away, right? Can we do anything with this whole thing? We really can't. We know this is not a perfect square. But this one is, because this could be 3q squared, 3q squared. But because it's not a perfect square, it cannot be factored. Okay. How about, let's do another one. Let's do the 100x squared minus 4y squared. Is this a perfect square? Yes, it's 10x times 10x. Is this a perfect square? Yes, it's 2y times 2y. Well, since there's a minus sign, we could just put it together. 10x plus 2y times 10x minus 2y. And we have our answer. Okay, I hope this helps with this section. If it doesn't, please, before you submit, tell me you have some questions for me so that we can try and go through those and see what else I can help you with to make sure you understand.